Perfect. Welcome back to WICKERSON Studios. Dan, just to move my face out of the way, we're going to continue with the geometry to the point beyond Python node at WICKERSON Studios. And our next exercise, we're going to skip over the basics. We've already jumped into geometry points. Let's do something else with points. So jumping in again so you can see your nodes. This will be the second video. And let's begin with the Math tab and bring in our Python node pretty much from scratch. We might have some prep to do for it, but I think the best thing to do is while we're writing it, just going to turn this one off. I think I'm going to drag this one down here so I can just click it to disable. And what we can do is work within this window. Most of our data will stay to this framework of X and Y, which I've said in the last video. And let's begin with our script editor and see what we have to write code in Ghpython. We'll erase all the other script. And I'm gonna do this each time till you get used to it, because you should get in the habit of it. So let's import. And this time we're just going to do Rhino script syntax because I don't anticipate using Rhino geometry or any other namespace. So Rhino script syntax, and we'll start to use the tab so we can autocomplete as RS this time, not making the mistake we made in the last video. Let's create a point list, and you do that by points equal. And if you want a list, you put it within what I think of more of as an array because I'm getting in the C#, and let's just do square brackets for it. Another space between it, and let's try our first iteration. For I, being a variable in range, and if we want the range to be something, we can call it anything we want. Let's call it X. Make sure you do your quotes at the end of it. As soon as you do something like that, realize you're in here dealing with a range X, and a range in Rhino script syntax and written the way it is now, not an F range or not dealing in C or something more difficult or breaking up the range into, you're going to have to deal in integers. So we'll leave it as a item access and we'll set our type into integers, and that's up and running. I'm not sure if I'm going to use Y yet, but let's just leave it. We have one of our data set as we're writing our script. We're going to make a variable point, and we're simply going to use the Rhino script syntax to append. And you'll see that comes up immediately. We're going to use that to use the language of Rhino script syntax, not Rhino geometry as point three doubles. We're going to add this as add point, and that should start to come up autocomplete. And we will make that point I, and we will offset, just to make it interesting, in the Y direction, the variable Y, which we can use as a float, and we'll leave the Z, keeping it flat at 0. We then have to take the points, and now we have to do the appending of the list, which is a tool for working lists, and that should come up dark. So let's just hit point and hit append. It didn't, but it'll go dark now. We're going to append it with the points. And at that point, let's slide back to the beginning, not tabbing in, and points underscore out will be set to points. Pretty simple script. Let's test it. It will have a problem because we have no integers set for X. So we'll have to drop in an input from a number slider. And we also have nothing brought into Y, but we also haven't declared Y. So let's take Y and declare it as a float, which will have a decimal. At this point, I'm going to set it to 2.9. You'll see exactly what happens in the Y direction. This should be interesting. Our output, if we take a look here, there's no attribute append. And the reason being, I set up a list as points list, and then I tried to append the point. Well, it doesn't understand that because the point is just a variable which is made at these points. It's not a list, so I've got to make sure I'm appending the points list. And I don't mind making the videos like this because I constantly have a million typos, and I think everybody does, but they don't regularly show that with you. The only problem here is, as we take a look at what I've referenced, a good practice of doing is having a panel on your output so you can see your errors as they occur, but also having a panel on your output here. And since no A is being output, we're going to have to name our output exactly what we want. And we could name it point, we could name it points. We're going to name this one points out because we've set our points out to points, our list after it's been appended. Hopefully that makes sense. We'll run in here and do a test. We should have a series of points, and there they are. And they are running in the X in a direction, and they're being influenced by Y set at 2.9. Let's hit OK to close the script. Let's zoom in to see what's happening. You see we basically have a script that we can change its Y while changing its amount of points in the X. And let's take a look at the name of that node. Let's call it to the point underscore array of points. And I'll try to be consistent in how I'm naming this. Now, the one thing I want to do this time is this may be an interesting script. This may be your first user object that you want to call your user object with your first icon. And I'm just going to end with it for fun. It's not really worth putting up on my WICKERSON Studio board, but I have a section in here for, at least I thought I had a section in here for tests. Let's do it. Let's just click this, go up to File, hit Create User Objects. Let's go into taking to the point arrays. Let's call it that. Short form, to the point, array of points. Let's put it in a category called category to the point geometry. Or let's just do to the point WICKERSON Studios. So it's going to come up in that way. Let's give it a category. You know what? I'm not going to mind putting in WICKERSON Studio user objects, and I'm going to put it in to the point. So that's a category for to the point scripts, which are basically tests. And what I can do there is import in an icon, which is always nice. Over on my desktop, I think I have a little, at least I thought I had an icon. There it is. I can go choose it. Let's put it a little blue. Let's make it an odd color. Let's put it a warning red, like it's kind of a useless one to use. What I like about this when I hit OK is there it is. So now when I drag it in, I have a user object that's a bit different. I haven't compiled it, so you can actually still go in and see the script, and you can append it and change it. But what I do like, it's one of the best things, is for those who are used to using the bifocal tool, you don't need to go in here and hit on this node group, you know what I mean? And right click here and type, okay, that was TTP _ point array. Like, you don't have to type that to see that override that. And you don't have to go in and grab your bifocal tools to have a peek at what that is to get rid of the back one. That seems like an awful lot of work to do-si-do around when you can just go in and make yourself your own user object, and just by putting on bifocals themselves, it will actually do that for you and pop that up. You won't get that generic Ghpython script. You'll actually get the title of it. So that's it. We're going to have this little warning phase here, add our user objects as we go. And like I said, for the end, we're going to grab this and just put it back on enable. End up back with our shaded colorful view. At least I thought it would come up. There it is. Yeah, in all its color and glory. And we'll end on the same frame as making our second script. So hopefully you found that interesting. We're going in a little deeper, and let's continue. We will move on to conditional examples of what to do and how to write point scripts and problem solve as we go. Thanks very much for watching.